Hi, it's Mrs. Barnett coming at you from COVID 2020. I'm never going to stop laughing at that. All right, so today we are going to be able to solve problems involving tangents. And you're thinking, tangents, we did that way back in chapter 7 with the sine, cosine, and tangent. Well, tangent gets its line because, or its name because of this, because tangents are lines that are touching circles. So I know you're excited how I pull it all together. We're actually not, it's called tangents, but we're not even going to use trig functions. So first of all, a tangent is a line that intersects a circle in exactly one point. I like to think of a pencil on a hula hoop. Hula hoop. So it's a line that just kind of, you know what I can do? Girl. It's a line that just skims. Perfect. Skims it. It touches it at exactly one point. And the tangent line is going to be perpendicular to the radius. So it is a line that is perpendicular. Perpendicular. Or that symbol that we use, the upside down T, to the radius. So a tangent line is going to create a 90-degree angle with the radius. All right, so this is saying the exact same thing. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn at the point. So line L is tangent to circle S if and only if L is perpendicular to ST. ST being the radius of that circle. All right, so if it's perpendicular, then we know that JH is tangent to circle G at J. Find the value of X. So if we know that this JH is perpendicular, we know that this is creating a 90-degree angle. How would you solve for X? Did you think about it? I hope you did. I hope you thought, because it looks like a triangle and I've got a 90-degree angle, I can use Pythagorean theorem. So I'm going to put a little star and I'm going to make it pink so you don't forget. Use Pythagorean theorem. That's a squared plus b squared equals c squared. A squared plus b squared equals c squared. Now x is only from k to h, but could I solve for all of gh and then use the segment addition postulate to later solve for x? Yes, you could, and that's what we're going to do. All right, so the legs of the triangle are a and b, so that's going to be 5 squared plus 12 squared is equal to this whole distance gh, which I called y. So now we can just solve for y. 5 squared is 25, and 12 squared is 144. And now we're just combining and solving. 169 is equal to y squared. We take the square root, and y is going to be 13. But that's not the end because we're asking for x. So we're going to use segment addition postulate, and I even wrote a note. Use segment addition postulate. That's when the two small chunks add up to the large chunk. So GK plus KH is going to be equal to GH. So GK plus KH is going to be equal to GH. In this one, we've got GK. What is GK? That's a good question. Look at it. It's the same as this segment. It's going to be 5. GK is 5 plus KH. That's the X we're solving for. And GH is y, that whole segment is y, and we already know what y is. It's 13. So now we can just solve. Subtract 5 from both sides. We get x is equal to 8. If you want to skim past these two and try these two problems right here, they are very similar to that one. So let's do those right now. And we're going to use Pythagorean theorem again. A squared plus b squared equals c squared. This first one is pretty straightforward. The legs are going to be the a squared plus b squared equals c squared. The legs on this are BC and AC. So 14, because this is the 90-degree angle. So 14 squared plus x squared is equal to 17 squared. 14 squared is, what is it? 196. Plus x squared is equal to 17 squared, which is 289. I can subtract 196 from both sides. I get x squared is equal to 93, and then I take the square root. So x is equal to the square root of 93. The square root of 93 doesn't reduce. That's it. All right. I want you to try this one, and again, the hypotenuse is going to be a whole length here, y. So pause it. This one is just like my original example. Pause it, try this one on your own. All right, I'm going to assume you paused it and you tried it. First, we set up our original Pythagorean theorem. 4 squared plus 3 squared is going to be equal to this whole segment squared, which is y squared. So we get 16 plus 9 is equal to y squared. And we get 25 is equal to y squared. We take the square root. We get y is equal to 5. If you recognize that this is going to be a 3, 4, 5 right triangle, props, because that happens a lot. So this is a 3, 4, 5 right triangle. But if you didn't, that's fine too. I solved it. So we're going to use segment addition postulate to solve for x. We have to know that all the radiuses are the same. So if this radius is 3, this radius is also going to be 3. So x plus 3 is going to be equal to 5. We subtract 3 from both sides, and x is going to be 2. All right, those are great. Okay, these ones are a little different. They say to verify tangency. So the problem will say, is this line tangent to the circle? So you're going to use, again, a squared plus b squared equals c squared to ensure that this is a right triangle between the radius and the supposed line of tangency. So, but quick note here, unless you're asked to verify tangency, assume that lines that look tangent are tangent. So in any question that you're given and it looks like a line is tangent, you can usually assume that they are tangent, unless it says determine whether this line is tangent or not. It's just a quirky thing. So determine whether GH is tangent to circle F. So we want to know, is GH tangent to circle F? That would mean that this was a right triangle. And we can just set up a Pythagorean theorem. But again, this 4 is only this segment right here, so we need to make sure we plug in that 6. All the radiuses are the same. So we know that HF, the whole thing, is 4 plus 6, which is going to be 10. So when I set up my Pythagorean theorem, I'm making sure I'm using the whole hypotenuse and not just that small little chunk of the hypotenuse. So we set it up. It's 8 squared plus 6 squared. Is that equal to 10 squared? So we're asking ourselves this question. Is that true? A squared, or 8 squared, is 64, and 6 squared is 36. Is that equal to 100? 64 plus 36. Oh, it is 100. So yes, this one is tangent. This isn't my answer. My answer is GH is tangent to circle F. Is tangent to circle F. This is answering the question. Is it tangent? Yes, it is tangent. All right, let's try it again. Try this one on your own. Make sure you use the whole hypotenuse, this whole segment right here. This is 8, so this is also going to be 8, so all of kj is going to be 17. So when I set up my Pythagorean theorem, it's going to be jl squared plus kl squared is equal to kj squared. 8 squared plus 15 squared, is it equal to 17 squared? Let's see. 8 squared is 64, we just did that one. 15 squared is 225. 17 squared is 289. 64 plus 225, yeah, that's 289 is equal to 289. Oh, 289 is equal to 289. Check. So we do know KL is tangent to circle J. All right, and the last little bit about tangency is if two segments from the same exterior point are tangent to a circle, then they are congruent. So remember I said if they look tangent, I can assume they're tangent. So if AB and line CB are tangent to circle D, then they're both going to, they come to the same point, then they're going to be congruent to each other. AB is going to be congruent to CB. Okay, and I like to think about ice cream cones. Think ice cream cone. You see it, right? Here's the ice cream cone. Since these lines are both tangent, they're creating 90-degree angles, this segment and this segment are going to be congruent. So that's all we need to know. If I see an ice cream cone, I'm going to think those tangent lines are congruent to each other. So AB and CB are tangent to circle D. So I know that they are congruent. AB is going to be congruent to CB. If they're congruent, their measures are equal. So x plus 15 is going to be equal to 2x minus 5. And now I'm just solving, subtracting x from both sides and adding 5 to both sides. 15 plus 5 is 20. X is equal to 20. Done. All right, this one's a little bit trickier because there's lots of ice cream cones. You got to see it, and we want the perimeter. Remember, perimeter is the distance around the outside. Around the outside. Guess who's back? Okay, the perimeter distance around the outside. So we want the whole thing. There's some blank spots that we don't know. We need to find CD, and we also need to find AE. AE is probably easier because these two segments, because they look tangent, they are tangent. This part is 8, so this part is going to be 8. So now I know all of AB is 8 plus 7, which is 15, right? 8 plus 8, yeah. This is 15. This whole segment is 10, but so I really don't need to know that, but I need to know what this segment is right here to figure out this segment right here. I know they're going to be congruent to each other. They're the same. This whole thing is 10. Look at this is 7 and this one is going to be the same. So these two should add up to 10. So this segment has to be 3. So this also has to be 3. So then I know that 8 plus 3 is 11. And now I'm just adding up my distances. AB plus CB plus AC. AB, let's highlight them. AB is 15 and CB is 10 and AC is 11. So I can just substitute those in. 15 plus 10 plus 11, 25, that's 36. So it's 36 feet because it's a perimeter. It's a distance around the outside. All right, this one is reversed. It gives us, it says find x. It tells us the perimeter is 18, and we just need to solve. So this segment and this segment are going to be the same. So if this is x, this is also x. And if this is x, this is also x. And same thing down here. I see a bunch of ice cream cones. If this is 3, then this one's also 3. And if this one's 3, then this one's also 3. So you can only say that the ice cream cones are congruent. You can't say that these two segments are congruent. You couldn't say that x is equal to 3. But I do know all my x's and all my 3's have to add up to 18. So all my x's, x plus x plus x plus x, and all my 3's, there's 4 of them, have to equal 18. So now I'm just combining like terms. I've got 1, 2, 3, 4 x's, and 3 plus 3 plus 3 plus 3, or 3 times 4 is 12, is equal to 18. And now I'm just solving. Subtract 12 from both sides. 4x is equal to 6. Divide by 4, and x is equal to 1.5. That's it. We're done. Yay. Have a great day.